to discuss production, how to bring your deep learning models to production. Let me show you an example of what we are trying to build here. All right, so this is my web interface for the model, and it's live. It's deployed right now on AWS, and I guess this is going to show you the way it functions. It just returns a number that is 0 or 1, and the page shows positive or negative depending on the number that is returned by the model. All right, so the first thing that we are going to discuss is the machine learning workflow, just to see how this deployment part fits in the workflow. So machine learning workflow consists of 3 large areas. The first one is called explore and data process, and the exploration and data processing is the research part. Essentially, you are going to study a domain, and in business or science, and get a data set and clean up the data and figure out if you can extract features and knowledge to use. All that part is also done in our an example notebook, and is mostly not a part that we are going to be using much of SageMaker for. The tool that we're using, the service that we're using, SageMaker, is going to allow us to automate a good part of the second and third phases, which are the modeling itself and the deployment. For modeling, we have mainly 2 steps: the creation of the model and the validation. And we're going to show how to do that with SageMaker, and this part is a loop in itself. So you develop, train the model, validate, and loop probably several times to improve the quality before you move to the next phase, that is the deployment. So in deployment, we are only worrying about making that model available to people for inference, in inference mode. So this is a more straightforward workflow, but there are other concerns, like if you are going to show it to the open internet, how do you secure the input to your app? And for that, we're going to use another services from AWS that are very simple to use and very easy to escalate. Okay, and with that introduction, let's talk about the tool that we're going to use. This is a service that is called SageMaker and allows us to do what is referred as serverless computing in the web. So it's called serverless because you don't have to do the administration or setup or configuration basic of the servers. So traditionally, when you were working with cloud, you would have to first set up a server in the cloud, get it running, and then maintain it. In this case, because we are going to use SageMaker, we will use an API that will allow us to provision a cluster in the cloud and run a job for training the model there, and then store the models on S3, and finally instantiate provision a permanent deployment place where the model is going to run in a cluster or in instance, and the web page will query that. So all those steps are done are managed from a notebook, and when you train a model, a job runs provision machines to do the training, and when the training is done, it automatically terminates all those instances. So the administration of the server side is a lot easier thanks to this service. All right. So the first part of our data science cycle is going to be focusing mostly on what is called ETL, and essentially retrieve the data, transform it to create the features that you need, and upload it to S3 so the model can read it from there. So this is a regular data set preparation job, and in here I have some code extracted from some other examples, not from the project itself. So in this example you can recognize the three parts of the process. So the retrieval, the transformation, which in this case there isn't much to do because the data set is already ready to use, and if you're going to train, you have an additional preparation step that is splitting the data set and then loading the files. Finally, you can see the loading of the files. So here's the first place where you can start using the SageMaker methods. So for SageMaker, you just at the beginning of the code here, you declare a session, and then at the end you see how you use that session object with the upload data method to upload your data from a local path in your notebook machine to S3. So the place in S3 is going to be determined by this variable here called prefix, and it's essentially a path in S3. So the next step is the tokenization of text, because we're doing sentiment analysis. We're going to have to to break up the text in words, and then do some extra steps to clean it up. The traditional steps to clean up text are convert to lowercase, split the strings into tokens, and remove the stop words. Now I want to just a little note to warn you that those steps, although they are very common, they are not necessarily the best for if you want your sentiment analysis to pick up all the information in the text. For example, here you can see that if we call our review to words method with sentences that mean exactly the opposite, after removing the stop words, what you get are lists that are identical. So a lot of information was lost. So, but that's not the point of this presentation. We are focusing on how to do the deployment, and then you can improve your model any way you see fit. So the first thing that we're going to do is the text encoding, and this again it refers to typical problems in NLP to convert letters and words into numbers that the model can process. You're going to create an index that assigns one position in the index to each word, and once you have that, you can use that index, that is an integer, as an input to a model. There are two ways to do this. You can encode it as Well, there are several ways, but the most common ones are you can do one-hot encoder. So you one-hot vectors, they are vectors of all zeros with one single one single element that of value 1, and the other one, the one that we're going to use, is the embeddings layers. So embedding layers is simply a matrix that for each index it uses the index from the dictionary. So the index represents a word, right? So use that index to select a row in a matrix, and the row has a fixed number of columns, like 50 columns or so, and that row has then is an array of 50 elements, 50 real numbers that represent your word embedded in a 50-dimensional space. So those are issues that do not belong to this part of this particular webinar. So I'm not going too deep into that. I'm just mentioning that this is what we are using. So once our text is encoded, where another step that is I have to mention here is that we not only encode with the dictionary, but we also compute the frequency of each one of the words, and then by sorting them descendantly, we select the top 5,000. So we're cutting off all the words that are not most frequent. And that is also very, very standard in NLP, and since there is no way around it, you always have to focus on the most important words. I'm going to go a little bit deeper into that. So what happens when your dictionary runs out of fashion? Let's say today people are talking, writing reviews about movies, and they use certain words that are fashionable today, but in a few years there might be new words that become very, very used, and in the reviews of 5 years next, those words start to appear. They are very frequent, but today are not frequent at all. So we don't even have them in our dictionary. So you know what happens with when a word is not in our dictionary. We simply, whenever we see that word, we will replace it by an index. In this case is 1. The index means that this is an unknown word or an infrequent word. Essentially, we don't pay any attention to it. So all the unknown words go to the same bucket, which means for our model, we ignore the word as a particular coding point, and essentially we don't see the word. So this is a word of caution. The dictionary might change. Also, this also applies if today you want to apply the same dictionary that you develop for movie reviews to real estate or to human resources curriculums or resume reviews. The words are going to be completely different, and your dictionary is not adequate to the relevant words in that domain. So that basically help you understand, if you want, that you are going to need to update the dictionary, and when you update the dictionary, you need to update the model, and that is when having an infrastructure like SageMaker, it can help, because it makes it very easy to do, or very straightforward, something that you have to loop over several times. So okay, here's a more in-depth review of the data processing and the transform that we're doing in data processing, in particular to our project. So we're going to run this. We are going to run review to words, which is a method that converts the review in a list of words and cleans it up and does the splitting. And then the second part is going to convert those list of words into arrays of numbers, with the length of the array as a prefix. So we first let's suppose that we have this particular review. So for each one of the reviews, this is one review, it has 4 words. I suppose that after the removing the stop words, you end up with 2 words here, like and movie. So we this is what we have in words test. It lists as like and movie, and then when you do the convert and path data, you pass the word dictionary and your words test, which is this array, and then you end up with basically with the test X is an array that has the coding points or the number in the dictionary, the index in the dictionary of the 2 words. So here is a list with 2 numbers, 2 indexes, and here is the len, which is 2 in this case. But the test text array is padded up to 500, so there are 498 zeros following. So you still need a len to know when you want to inform your algorithm when what is the last word is significant, where the zeros start. Okay, then you can concatenate and that's it. All right, enough with that. Let's move into the training phase. For this, SageMaker has 2 types of well, I'm mentioning here that the artifacts are going to be stored in S3, and what we call artifacts in SageMaker is essentially the model parameters that are in a compressed tar, and it's just a matrix of numbers that contains the product of training, right? Whatever you end up having as inside the model once you have trained, which is a matrix of numbers, a tensor numbers. So the model weights, if you want. So also everything is done with Docker containers. So you have containers that already contain your framework, and they are deployed when you create a job. So let's see how it is done. So this is an overview, and sometimes you will see that some of this code that I pasted here, it comes from the exercises, not directly from the notebook of the project. In part because I don't need to put all the project in here. I have to, I'm trying to not to spoil it for you. So I use some of the other examples that are very similar. Okay, well, as you can see, these things are kind of straightforward, but the typical steps go like this. First, you're going to pick up the location of a container with a training algorithm for your model. And in this case, because XGBoost is already a pre-defined container, you can pick it up directly. But in our case, we're not going to do this. We're going to build our own. Okay, because we're going to build PyTorch, and we're going to provide code for our own model. So don't worry, you don't have to use a pre-used model. So the estimator class is what SageMaker call it estimator. Essentially, is the model once it has been deployed and put in a container where you can now use it to train. So see, you call the class estimator, and you pass the container that contains the predefined model here, and then set the hyperparameters. In this case, you have these are hyperparameters because it's XGBoost, and then upload the data to S3. So here you are going to do a batch process. Training is a batch process. So you have to upload the data to S3 where the container is going to read it from. And then once you do that, you have to define essentially some batch generator or as we call it here, the input processor. So all it does is wraps the data into a little bit of code that splits the data into batches. So your fit model, your fit below your fit is going to is going to read batches when it's training. Okay, sorry, I am falling a little bit behind. I want to speed up here. So let me see. So here's how we're going to train a job in our notebook, in our project. So if you look at point number 4 in the notebook, build and train the PyTorch model, corresponds to something like this. We're going to call the PyTorch class in SageMaker, passing the code that we have prepared to train the model. So here you see that there is an entry point defined, which is train.py, and that contains everything for training the model. As you see, in this case we are not using a pre-defined model. We're using directly anything in PyTorch. We pass the code. So you have to go to the train.py and define the inner steps of the training process in PyTorch, for we should be very familiar with this at the moment. And then let me talk about the evaluation step. So the evaluation step, we're going to instantiate a container for inference. There are 2 ways to do evaluation in SageMaker. It supports the 2 ways. The batch transform job, which essentially reads the data set from S3 and stores the output in S3 at the end, and automatically deletes, terminates all the instances that were instantiated for the job. So it's a nice way to run large evaluation jobs and unattended. You don't have to worry about terminating the instances or maintaining the servers. The endpoint, on the other hand, is a real-time deployment. It means that you deploy the model into provision a cluster of machines or one machine to deploy your model, and it stays there, always available and always billing you. So this is for when you really need a 24-hour, 24/7 real-time responses from your model. You're going to set up a real production place or a demo that people will connect over a few days. So in that case, you can put it into an endpoint, and endpoints, of course, are billing you all the time. But in general, it doesn't need to be a machine that is so powerful as the training one, so it's not so expensive. So, all right, let's go first to the batch transform job. There are examples of running a batch transform job in the notebook. So, essentially here I'm picking up from one of the other exercises that we have in the lesson. So when you call a transformer on the I think this is called the predictor. The HEV is the predictor object that you formed before. You call the transformer method, and decide how many instances you need. That's going to create the transformer job. And when you call the transformer to the transformer job, pass the location of your input data and how is it encoded. Is it CSV or what is it? And then you have to wait for the service to provision the machines, run the job, upload everything to S3, and once that's done, this wait method finishes and gives control to the next line, which is where you download your results from S3. You have to download the results from S3 and then analyze them locally. Okay, so this is a large slide, but this is very important. This is the predictor, as opposed to what you just saw, the job. Now you are really instantiating a cluster and leave it there. So to manage the life cycle, you usually what you do is you call estimator deploy, and that provision the cluster, and then you have to specify the serialization type of your data. You are going to be sending data over the internet, so this is not a CSV file on S3. This is just a packet that comes on the internet with JSON inside, probably, or here you're going to specify the format. So for each request, the client processes call predictor predict, parse the results, and then well, when you are done with the with your demo or your production, you can shut down the endpoint. But in the case of your project, whenever you are done, just shut it down. In a real production environment, of course, you don't shut down the predictor. So the difference between the predictor and the batch is that they are summarized down here, and in the code you can see a reflection of what the slide is describing. Okay, the next step in the process is going to be to test the model. So we deploy the model to an endpoint for testing, and we do not provide, pay attention in the notebook, because the first time we do this, we do not provide predict or inference code ourselves. So SageMaker provides a default one, but the default one might work only for the simplest cases. And I have noticed that it's possible to run into trouble with in this step, because the default predict sometimes may have problems with GPU versus CPU arrays. So if you run into problems, just I can help. So just book some time with me currently, and I'll try to take a look at what is your case. So once you have deployed the deployment done, we're going to test the model in the real-time deployment, and for that we have this code here that splits the data set, the test data set, into batches and sends the batches. And when we also can predict using a single review. So a single review is a line exactly like the web page is going to use the model, sending one review at a time. And you have to do all the conversion in the notebook before calling the model, because as I said, we haven't provided a predict.py, which is a code that would do the preprocessing in the backend once we have the final application. So at this point, you just do the preprocessing here in the notebook, and then send the feature vector of numbers directly. So Let's review then what we have been talking about in training and evaluation. So the SageMaker commands that you are going to use are listed here, the 7 stages. You get the session on SageMaker, upload the data, then you can create an estimator with your own code. This is very important. This is how you're going to use it. So you use PyTorch, entry point train.py. This is where you create you put your training code, and then you call fit with the input data. You're still fitting with input data that is in S3, and then once you have the model created, you're done. You don't have to retrain it every time, but every time you want to deploy, you call estimator deploy with, but you have to create the estimator with. You have to know how to create the estimator with the files that are in S3. This is not shown. I don't think it's shown in the notebook, but you can figure it out. I can show you how to do it. So okay, so your application is going to call predict. Once you want to shut down your application, you shut down delete the endpoint, and that's it. Okay, so production demo, the code that you saw is built this way. I have hosted my page in S3 static web hosting, but you can host it in your laptop or anywhere you want. And it's going to go through an API gateway endpoint, and that is just a way to allow you to call it without having to resolve any security credentials. And that is going to call a lambda function, which calls the endpoint, and the endpoint returns to the lambda function, returns the results, which pass it through the API, and that's going back to, well, it's actually going back to your page, not to the user directly, but okay. So here goes the architecture again, and I have added some explanation in this slide of why do we need the API gateway and the lambda. So a little bit more on that. It's a web app design that essentially we're saying, okay, what's the problem that we have is that we have an endpoint deployed to and listening, but we know how to call it from the notebook that created the endpoint, but how do we call it from some other place? Then that doesn't have the. So we use the name of the URI of the deployment machine, and you will see how to do that. So how to create a web app step by step? Well, you have to add a lambda function, and inside the code of the the lambda function is simply passing through the data. It gets the data from the web page, pass it directly to the next thing. So inside this code, you have the reference to the endpoint. So the lambda function knows the endpoint, knows how to call the endpoint. So it's that's its function. The API gateway is simply knows how to call the lambda function from anywhere without a security issue. And the web page is just up to you, but it's essentially we provide one that is very simple. All right, so finally, predict. This is another little piece of Python code that you provide, and is called whenever the model is calling inference during the application. And all you have to do there is add the pre-processing steps, so convert the review to words and the words to numbers. So the page can call model forward, and then when you get the output, convert it back into a 0-1 number. So well, as promised, I want to show you how to create a new endpoint from a trained model that is in S3. So you can do this with a simple. The only thing that is different than what you have in the notebook is that you have to save the name of the endpoint, and put it into the Lambda function. Okay, so some details on how to create a gateway, and they are kind of straightforward, so I'm going to gloss over them. And finally, in the web page, you have to put the reference to your gateway function. So you have to do those two edits, and then we end up with the end page. If you want to know more, please give me book a session, and we can talk one-on-one. I will have to stop now because getting close to an hour. And with that, before we end, I want to show you briefly how the things look in AWS. So you see, with SageMaker, this is the SageMaker instance that I'm using. The SageMaker here that you see that is in service. This is where my notebook is running. From here, I open Jupyter, and this is Jupyter running in that notebook. And my notebook is a SageMaker project. So here's my notebook. This is what I have run today to do this demo. I have added this part, which essentially it tells me, okay, what do I have in S3 already trained? And it looks like I have a bunch of models already trained there. So I pick one of them and instantiate it. So, and this is my predict code that I'm going to deploy when I instantiate. So I do I deploy here, and I pass my predict code here, and I also pass the model that I have in S3. So one of these models. Okay, I have to give that to the notebook, and it's going to instantiate it. So some testing just to make sure it's good. You don't need to do the testing to do the app, but here is the name of my endpoint, and I have to put it in the Lambda function. So I paste it here in the Lambda function, and once the Lambda function is done, I can test it. Essentially, I had to create a test there that says, okay, it returns 0, which is negative, because I pass a text that is essentially says horrible movie. So the test is good. So okay, with that, guys, my voice is off. Right? So with that, I'm saying goodbye to the next one, and I have lots more of slides, but they don't belong necessarily to this project, so I'm not showing them, but I will be happy to show them and do another presentation if somebody is interested. All you have to do is just let me know. You can find me in Slack, in Udacity, or yes, just book some time with me in Calendly. And yeah, hope you enjoy this presentation. I don't know if I have a final slide to show, but it's probably good. Okay. All right, guys. Thank you. And trying to find a way to stop this. Okay.